Well, howdy again, everybody. Welcome back. This is going to be a lecture or a mini lecture on the power rules in the review section, chapter 1 of our text. And this is about, these are the kinds of rules, or if you don't like the word rule, you can write shortcuts, which I like better, that allow us to manipulate algebraically different things. So in our chapter, we're dealing with polynomials. We have to add, subtract, multiply, and divide is what we're leading towards now. In order to do that, we need to know these rules, if you will. So there's three of them. There's the product rule. Here it is. This is where, as you can see in this example, let's study this example together. They're asking us to multiply stuff together. They're asking us to go 5x to the fourth times 12x to the eighth. And I'm showing you all the steps for doing it. And these moves or maneuvers are known by successful algebra students throughout the ages. You multiply the coefficients together. See, I'm going to go 5 times 12 is 60. And you add the powers of the variable together. Why would you do something like that? X to the 8 times x to the 4 is x to the 12. Well, you have to understand what you're doing. First of all, what allows me to write 5 times 12 instead of, why am I allowed to manipulate that? Well, because the way I would do this in beginning algebra is I go, this is 5 times x times x times x times x times what else? 12 times how many of these guys? 2, 3, 4, a couple more, a couple more. That's what this notation right here is all about. Okay? So, of course, we can move things around and go, oh, it's really 5 times 12, and it's all those x's, all of them. So you end up with, well, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You add them together. So it's x to the 4 plus 8, and that's how you get your answer. So down here, way down here, I have an expression that I use a lot in algebra when I'm teaching people for the first time this subject. When in doubt, write it out, and you can see the mechanics. Now, I don't recommend you write this out, all the x's and stuff. What I want you to do is understand it and then use a shortcut. And the shortcut, the product rule, is the one that says x to the 4 times x to the 8. Don't write them all out. Just simply go 4 plus 8 is x to the 12. That's a shortcut for us. Okay. I have some notes here about what terms are all about. The terms are the number of things being added. So I have this example, several examples. 18x squared minus 6x minus 10 is actually three different things being added, subtracted. So therefore, we call it a trinomial for 3, triangle, what else? Tricycle. And of course, if it's two terms or one term, you've got the term binomial, monomial, and anything else, you just call it polynomial. All right. On to the quotient rule. The quotient rule is when you're dividing, and that helps us in another section in this chapter on division, where we might have to, as you can see here, divide a monomial by another monomial, one term by one term, for example. How do I do that? When in doubt, I write it out. But look how I did this one. It's kind of small, I know. I can maybe enlarge it. In fact, I think I'll try. There we go. A little bit bigger. You got 12. I wrote as 4 times 3. 16 is 4 times 4. Why did I do that? I want to cancel the 4s. That's how you reduce fractions. Well, you do the same thing with the x's as well, but you have to be just as clever as you are with numbers. Oh, 4 times 3 is 12. Why didn't I use 2 times 6? Well, I'm trying to cancel as much as I can. Look what I do with the x's. X to the 8 over x to the 5 is x to the 5 times x to the 3. 3 and 8, 5 make 8. And I did that so that the x to the 5s can cancel. Right? This is a different way of doing it. And look who survives. Upstairs, you got a 3. You got an x cubed. That's upstairs. Downstairs, you got a 4. So your answer is this. Notice what I said. Or it could be written a different way. Let's explore that. 3x to the third over 4 can be written as 3 over 4 times x to the 3 over 1. You know how you multiply fractions together? Well, then you can write this as 3 over 4 times x cubed. Oftentimes it's good to write it that way. So these are two different ways of writing that particular answer. But observe the next example. 21x to the 6th divide by 33x to the 10. Anytime you want, you can pause it and stare. I'm kind of going fast for, keep the tape short. What we have here is we've got, 21 is 3 times 7. 33 is 3 times 11, so I can cancel the 3's. X to the 6 over x to the 10 is x to the 6 over x to the 6, and 4 more make 10. I can cancel the x to the 6's. Clever, clever. What are you left with? You're left with a 7 upstairs and an 11 x to the 4 downstairs, and there is your answer. Question, can I write it the same way as I did the top one? Is there another or? Well, let's explore that. This is 7 over 11 times, well, this guy here with x to the 4 downstairs is not x4 over 1, it's 1 over x to the 4, isn't it? Okay, so that doesn't go anywhere. But if any of you remember negative exponents, you can write this as 7 over 11 x to the what? Negative 4. What the heck is the negative? Well, we'll explain that when we get to the exercises, but that's another way you can write the answer. See, the negative says it's x to the 4, but it's downstairs. So negative power really means, and there's a fancy word for flipping over, it's reciprocal. Okay, reciprocal power. All right. They're now also useful. In fact, I didn't say any of this. This is good for division. The one above here is good for our next lecture, which is on multiplication. But now you have the power rules going on. You got, what if you take a power to a power? What if this happens to me in life? And it will, because you're in algebra. You got, well, again, I say, when in doubt, write it out. B to the 6th to the 4th power means the base is multiplied with itself 4 times. That's what the 4th power means. So I wrote b to the 6th times b to the 6th times b to the 6th. It gets kind of boring. But the product rule says, add the powers, 6 plus 6 plus 6 plus 6. Well, I know what that means. It's 6 multiplied with 4. It's 6 4 times. And therefore, I get b to the 24th. Well, the shortcut says, don't do all that writing, just multiply the powers together. And that's what students of algebra know. When you take power of a power, you multiply the powers together. It's nice, it's quick, it's easy, it's fun. If you extend it and really start challenging yourself with problems, look at this one, the extended power rule. Apply the power to every factor within the parentheses. Here's another example. I've got this stuff, whatever it is, to the 5th power. That means stuff times itself 5 times. That's what the 5th power is all about, right? That's what the 4th power up here was all about. Okay, so then if we know fractions, that means we multiply the tops together, the bottoms together, and you see I've got 1, 2, 3, 4, 5 multiplied together downstairs, the same story. And now you do this lesson from above where you're multiplying 3 times 3 times 3 times, there's 3 to the 5th, y to the 4th to the 5th, 2 to the 5th, x 6 to the 5th, and that is the extended power rule story. Instead of doing all that stuff, all you do is you apply that outer power to everybody inside. Everybody inside gets the 5th power. And then, of course, 3 to the 5th, calculator, 243. Here we go, y to the 4 to the 5th. You multiply the powers like we did up here. 2 to the 5th is 32. X to the 6 to the 5th, 6 times 5 is 30. And that's the extended power rule. So there's a lot here. I thought this would be a short tape, but it's not. There's a lot of stuff going on here with the manipulations you do. They all have to make sense to you. That way you'll remember them. So what I did down here in the next page, I kind of explained the negative exponents, but only a little bit. The negative exponent story is this. They teach a, don't you do that. Don't glitch. They teach the quotient rule the following way. Instead of writing it as I did, which is x to the 3 over x to the 3 times x to the 4. Cancel and get 1 over x to the 4. You follow? Instead, the quotient rule has really said write 1x, take the top power, subtract the bottom power from it, and if you do it that way, you get, what do you get? What is 3 minus 7? It's negative 4. Here's what it really is. Here's a new notation with negative powers, and again, you can see, hey man, that's a good reason why the negative power is a reciprocal. Okay, pause and think about it. I know you can't ask questions, but these notes are here for you to listen and watch and go back to again and again until maybe it makes sense. So in this case, I'm doing it one way, which is the actual official quotient rule, but I also do it a different way here, making a big mess, aren't I? Okay. So I want you to take a look at these 4 exercises on the product rule and multiplying stuff out, and pause the tape and do them. And I'll wait. Okay. And let's start up. Let's see if you got the same thing. Let's see. So I would, in this problem, I would take the minus 12 times 3 times x to the 5 times x to the 8. Some of you might even be skipping that step, which is awesome. And you just go, oh, it's minus 36. X to the 5 plus 8 is 13. Who got that? Raise your hand. Good job. Good job. 1 for 1. The next one, minus 6 times minus 9 times x to the 12 times x to the 7 is positive 54. X to the 12 and 7 make 19. Who's 2 for 2? Good job. All right, so that's what you're going to do in the next section on multiplication, but you're going to do it a few times and combine like terms. All right, this one. I'm getting minus 2 times 7, watch what I do, times x to the 5. I'm going to put the x's together, and then I'm going to put the y's together. So I'm going to multiply the coefficients, minus 14. I'm going to add the powers, 5 minus 2 is 3 for the y, minus 8 plus 6 is minus 2. And folks, that's a good math answer right there. However, if you're in an algebra class, they often do this to you. So will my math lab. No negative powers. No negative, they'll say exponents. Write it without negative exponents. They want to see, it's just a thing that they make you do this to show or make sure you understand negative powers and what they mean. So for this then, if I do have a negative power, and I do have a negative power, then I'm going to draw a line, and I'm going to send the negative power guy down as a positive power. And I leave everybody, including the negative 14, even though he's negative, so what? It's a number, and then x to the 3. And that is a good answer right there. So maybe we fooled you on that one. Maybe you stopped here. I didn't say to go farther. This is, like I said, a good math answer. Good job. Let's try it now. If you got that, you can fix this problem if you want. You can pause it. But I'm going to attack it right now. And again, it's negative 2 times 7. I don't know why I didn't change those numbers. Who cares? We have x to the minus 5th times x to the minus 2 times y to the 3 times y to the negative 5th. And again, we get that negative 14, but now we get different powers. We've got x to the minus 2 minus 5 is minus 7. And y to the 3 minus 5 is minus 2. Again, good answer. Good job. But if they say no negative powers or no negative exponents, you draw a line, and anybody with a negative power, this guy or this guy, goes downstairs. So I'll bring the x downstairs as 7. I'll bring the y downstairs as a power 2. And I leave the negative 14 upstairs because he's not to a power that's negative. And those are the answers. Maybe you got 4 for 4, except you didn't do the negative exponents, in which case, excellent. Excellent work. I have a few more to do. Why don't you practice these? I don't know how much longer we can go on this tape. It's kind of long. Pause it. Okay. So I'm going to do that technique here where I just write it out. 12 and 4, you know what happens there. I'll show it to you. 4 times 3 over 4, and we're going to cancel the 4s. I have x to the 4 times another x to the 4. I know it's tempting to divide those powers. You don't ever divide powers because you know why? Because it doesn't make sense. You're supposed to cancel stuff. There, that's done correctly. The answer in this case, the survivors are 3x to the 4th, and that's it. It's 3x to the 4 over 1, or you don't need the 1 there, 3x to the 4, and the 1 is implied. But if you leave it there, I won't penalize you. Okay, next one. Do the same technique. Well, minus 5 into 75 is no problem because this is like 5 times 25. Downstairs is a minus 5. Questions I get are, can I cancel 5 with negative 5? Yeah, you know why? I'll write it a different way. Because this is like minus 1 times 5. Aha! Up here is a squared. Down here is, I know, 2 and 10. Excuse me, something's happening. I'm going to write it the same way, a to the 2 times a to the 8. See how that works mechanically? Cancel the 5s, cancel the squares, and write your answer out. You get a 25 surviving upstairs. It's a matter of who are the survivors. We got a negative surviving, negative 1 times a to the 8. Okay, it's a weird way of doing it, but it works. Oftentimes it's good to move the negative out in front. It just looks better, and sometimes you have to, and get used to that idea. So a couple more. Remember how to do these guys? Did you do them? Well, what I learned was a shortcut says 3 to the 5th, x to the 7 to the 5th, which you can do in one step. Some people are doing this in one step, which is beautiful. 4 to the 5th, those lucky devils, y to the 4 to the 5th. And we're getting, well, 3 to the 5th. I think we did it before. What is it again? I forget. 81 times 3 is 243. Multiply the powers, remember? X to the 35 over 4 times 4. Oh my gosh, 4 to the 5th. I didn't calculate that. What'd you get? Help. It's 16 times 16 times, that's 2 to the 10th. Okay. 32, 64, 128, 256, 512. Is it 1,000? 1024, I'm guessing? 1024, y to the 20th. I think that's right. And the last one to see, it's 2 to the 3. Let's see if we can do it fast. Multiply the powers. Guess what? R 18. 5 to the 3. Multiply the powers. M 36. So an answer, 8R18 over 125 M to the 36. Box it for lunch. You're done. I know I did that fast, but that's how fast it can go. And all right, next stop is polynomial multiplication.